Let's take a look at Chapter 12, Problem 3. We have a rectangular channel that has a width of 2 meters. If the flow is 5 cubic meters per second, determine the Froude number when the water depth is 0.5 meters. At this depth, is the flow subcritical, supercritical? Also, what is the critical speed of the flow? So in this example, let's see what we're given. So we're given the width of the channel. So in the formulas, remember that is B. B is 2 meters. We're given the flow, 5 cubic meters per second. So is that big Q or little q? Oh, that's big Q. We're also given the depth of the water, which is Y. .5 meters. So what formula are we going to use? In this case, we'll use the formula we need to find the Froude number. So we're going to use the formula FR is equal to V over the square root of G times Y. So we know what G is. That's obviously the acceleration of gravity. We know what Y is, but how do we find V? Well, we have to fall back on the formula that we have that relates the volumetric flow rate to the velocity and area. So we have V equals Q over the area. So what's the area? It's a rectangle. So it's the width times the height. So it's 2 meters and 0.5 meters. So this turns out to be 5 meters per second. That's the velocity. So now we can plug these into and find the Froude number. So the Froude number is 2.26. So what can we say about this number? First of all, it's greater than 1. So what does that mean? Since it's greater than 1, that means it's supercritical. So let's look at the second part. At this depth, is the flow subcritical or supercritical? Well, we found that it's supercritical. What's the critical speed of this flow? So first of all, let's find the critical depth. So you can look this formula up in the book. You can plug in the values. We know what Q is, we know what G is, we know what B is. So when I calculated this, I got 0.8605 meters. So that's the critical depth. And so we want to find the velocity at the critical depth. So we can find that using the formula we have in the book that says V equals square root of G times Y. So in particular, at the critical depth, we just have to plug in that value. .8 meters per second squared times the 0.8605 meters. So the velocity at the critical depth, we'll put a VC on that, is equal to 2.91 meters per second.